right, in this video, I'm going to give you a little intro to graphing linear inequalities. Go ahead and pause the video and copy these notes down. Welcome back. All right, as you can see, there are 4 different ways to write linear inequalities. You may have it where it's in y equals mx plus b form, but it may have a less than sign or a greater than sign, less than or equal to sign, or greater than or equal to sign. If it's strictly less than or greater than, it's a dotted line that when you graph your line on the graph. Or if it's less than or equal to or greater than or equal to, it's going to be a solid line. And also, you remember the cheer I taught you guys in class? If it's less than, shade below. If it's greater than, shade above. All right, let's look at some examples. You see this graph? It has a dotted line and is shaded above. And how I know is that if I was to draw an arrow pointing up, is that arrow in the shaded area? Yep, that's how I know it's shaded above. Let's see if I try to draw an arrow pointing down. Is that in the shaded area? No, so it's obviously not shaded below. So being that it's shaded above, and according to that cheer, it has to be either greater than or greater than or equal to. But as you can see, it's a dotted line. And remember, when it's a dotted line, it's strictly going to be greater than. So I'm going to use my greater than sign. Let's look at another example. Same one, but this time it is shaded below. How I can tell is that if I draw an arrow straight down from the line that's on the graph, it's going to be in the shaded area. And remember from the cheer, if it's less than, shade below. If it's greater than, shade above. So since it's since it's shaded below, it's going to be less than. And again, since it's a dotted line, there's no equal to. All right, let's look at this example. If I was to draw an arrow pointing straight up from the line that's on the graph, would it be in the shaded area? Yep, that's how I know it's shaded above. And remember, when it's shaded above, it's going to be greater than. But, as you can see, it's a solid line. So that means it's greater than or equal to. Let's look at the last example. If I draw an arrow pointing straight up from that line, is that arrow in that shaded region? No, so it's not shaded above. But if I draw an arrow pointing down, would that be in the shaded region? Yep, that's how I know it's shaded below. So since it's shaded below, it's going to have to be less than. And if you notice, it's a solid line, so it'll be less than or equal to. And one last thing I want to point out is that the shaded region on these inequality graphs represent the solutions. So when it asks, hey, is this point a solution? All you got to do is plot the point and see if it's in the shaded region. Let's look at the first example. -2, 4 will be right here. Is that in the shaded region? Yep, so that's the solution. What about 2, 4? Uh-oh, it's right on top of the dotted line. Guess what? It's not a solution because the line is dotted. And what about 4, -3? Well, that's down here. Is that in the shaded region? Nope, so it's not a solution. Let's look at this graph over here. -2, 3. Well, that would be right there. Is that in the shaded region? Yep, so it's a solution. What about -1, 6? Well, if you notice, it's right on top of that line. But guess what? It's a solid line. So therefore, yes, it is a solution. And then what about 5, 2, which is right here? Nope, not in the shaded region. And that's it.